Hi, I'm going to talk about weights and measures. And that's the most important thing that you should take with you is the ability to weigh out uh, a sample. Very important to develop this. Usually solids and liquids, sometimes gases, but for the most part, for sure, solids and liquids. In the classical physics reference frame, right? Okay, this is the old Roman weight system for precious substances, the apothecary weight system. It was adopted from Romans to the Druids in the Dark Ages. Merlin and the magicians would use this. Even to modern day, you have these apothecary weights that are carried through. And I'll give you an example. This is just to show you how important weight is, right? And when you're dealing with substances that are worth a lot of money, like chemicals, for example, in the laboratory. Some chemicals are worth, $1,000 a dram. Very expensive. Okay, apoth is another, just a shortened word for apothecary. Here it says apothecary, apothecary. It is 4 ounces, 5 ounces, 2 ounces, and 1 ounces that they have here in apothecary weight. I suspect that it's about the same as regular bath scale weight, but there's a little deviation. I'm not going to talk about that in particular. I just want to impart how important it is to learn or appreciate the weights and measures. Okay. Yeah, apothecary. Here you have 240 grains. It's like a oh 45 caliber bullet is about 240 grains. I don't know if I should say that, but that's what comes to mind. That's what comes to mind. Okay, so you have 240 grains. You have well, um, dram. I think this is dram, but it's spelled funny. There's a scruple, and this is one scruple. This is two scruples. I thought that was kind of neat. And they have them in these brass weights standards, so that you have maybe this standard. If a person wants 240 grains of something, it's very expensive. You put this standard weight, and you weigh out the chemical herb or whatever it is that he wants for a tincture or medicinal dose or something. Okay, here's the alchemist ether symbol. This is ether. It's an alchemist symbol. Uh, it's been subject to a lot of debate. Mesmerism, mesmerized. It's really a magical kind of idea that the alchemists were magicians back in the old days. So they believed in this ether. Some people still believe in ether. I'm kind of a skeptic about ether, but I can understand how people could actually believe this concept in modern day. Okay, for example, the fifth element is the ether. Here is an old periodic table that I got off the internet. You have water, air, fire, and earth, and the fifth element is a unifying element in the Babylonian or Chaldean calendar, where you have the zodiac, right? Turns out that the Chaldeans made the calendar all about 3,000, 2,000 years ago in the old, very long time ago. And they based their calendar on a perfect circle. It's 300 degrees in a perfect circle. And if you divide 360 by 12, you get 30. So you have like 30 days roughly per month, and you have 12 months. And in the zodiac sign, they had constellations in the northern hemisphere that they assigned per month. So let's say they had, Scorpio, right? Constellation of Scorpio, a certain month. They assigned that to a certain month. And apparently Scorpio is a water sign, so they staggered these in a quarterly basis. So you have 1, 2, 3, 4, right? So you have like 4 quarters in the year, and these are always adjacent to each other. You never have like two fire signs next to each other. So it's just the way the Chaldeans came up with the zodiac. Now, there's also the fifth element, and that's the ether. That's what the Druids came up with in the mysticism of alchemy a long time ago. Okay, here's an old periodic table. I try to find ether somewhere written here in the periodic table. I think I remember hearing ad hoc that there was some old table that had elements with the ether included, but I'm pretty sure that was a very old table before Einstein's time. Okay, because Einstein disproved the ether in his theory of relativity, where E is equal to mc squared, you had the propagation of waves in vacuums. They postulated that you needed an ether in order to propagate electromagnetic waves, and Einstein disproved that because he was able to prove that these waves travel in a vacuum. And so there you go. This is a very skeptical idea. Um, Even the modern day fermion Higgs boson, um, they wrote a book about it called the God particle. But even the inventor of the boson itself was very uh, skeptical about this particular book. He just thought it was mumbo jumbo. Anyway, I don't know. You have Harry Potter and so on and so forth. They're good movies. I haven't really seen a Harry Potter movie, but I can understand where you can get you know appreciate the mysticism associated with the old Druid way of thought. Okay, here's another old periodic table. Just thought I'd show it to you. There, mystical chemistry. There you have the expanding universe, quasars, galactic clusters, black holes, galaxies, star systems, sun asteroids, comets, the Kuiper belt, gas clouds, Jovian planets, Jovian moon, weather, planet, continent, ecosystem, tribe, and individual. Uh, yeah. Okay, now here's the mathematics behind what is, as far as I could tell, modern day mysticism, which is a Schrodinger equation invented by Schrodinger, who was Einstein's contemporary. Now, they weren't really trying to disprove the ether in particular or anything along those lines, but this is a cornerstone for quantum mechanics. This is the equation that explains a lot of quantum mechanical phenomena that should not happen in classical physics, but they happen anyway. And this equation accounts for a lot of quantum mechanical uh, phenomena. Like there's the alpha decay, there's the beta decay, there's the gamma ray form of decay, and sometimes electrons and protons tunnel, and they don't know why it happens because these protons and electrons don't have sufficient kinetic energy to surmount the potential energy barrier, but they do it anyway, and they call that in truth they call that tunneling. It's just a phenomenon that is explained by this very difficult upper higher order mathematical second differential or tridifferential equation to solve in partiality, right? So it's very difficult, very abstruse. Only peak chemists and maybe some guys in the Vatican that have PhDs in chemistry may be able to understand this from an intuitive level, but I have yet to do so. So I brought up the mysticism just to lead into the Schrodinger equation. Now, mysticism uh, is okay. Um, I was at the University of North Texas at Denton with an analytical chemist who said that the difference between a theoretical chemist, which is what this is, and an analytical chemist is that an analytical chemist has a job. I mean, really, applied science, when it comes to invention in the classical aspect of practicality, is different than this kind of thing, right? Now, you have to hand it to them that they can do this. I can't do this, but I think it's very attractive to see this equation. It's just that I put it up, and along with the mysticism, just to show that some things other people can do and some things other people can do. All right, this is something I cannot do or really quite understand at an intuitive viewpoint, but it exists, and it is something that is quantum. Okay, here's in the previous slide they talked about the Fibonacci sequence and with respect to the Schrodinger equation. This is a spiral of Archimedes. This is an example of tunneling. This is a potential energy barrier, and these guys don't have enough kinetic energy, but they tunnel through this potential energy barrier right there, and these little particles end up over here, even though they shouldn't be there. That's just a cartoon way of what they're talking about. The Schrodinger equation goes into the mathematics and the vector calculus, I suspect, to go about with expectation values and eigenfunctions and solutions to a particular system that's in question, right? Okay, this is a firefly. This is an example of classical electronic transitions that are allowed. This, I think, bioluminescence. It reminds me of phosphorescence, fluorescence, and it's bioluminescence in the firefly. This is an allowed transition, I'm sure, based upon the biochemistry within the firefly itself that imparts enough energy to the electrons to go about their excitons and emissions and relaxations to emit this light. One way or another, there may be some quantum chemistry going on here anyway, right? Because you have subatomic particles like protons and electrons that are part of the cascade and energy gradients associated with biological systems. This is a case in point, but for the most part, this is an allowed electronic transition. All right, just thought I'd differentiate what is allowed and what is difficult to understand. Classical electronic transitions are very simple to understand, and that is what we'll be dealing with for the most part in this course. Okay, that's about it.